Good morning students. So in this last session of your states of matter, we will be going to discuss about the liquid state, that is till your previous session we have completed your gaseous state. Now we are going to discuss about the liquid state, and this is your last session of states of matter. So liquids is the state of matter having a greater intermolecular force of attraction when compared to your gaseous state. That is, the intermolecular force of attraction increases from gases when compared to gases, as well as the thermal energy decreases when compared to the gases. Then you get a state of matter which is called as liquid state. So liquids are obtained by the increase in intermolecular force of attraction and decrease in thermal energy when compared to gases. The state of matter obtained is liquids. So liquids are the state of matter which has greater intermolecular force and less thermal energy when compared to your gases. So increase in intermolecular force and decrease in thermal energy gives you the state of matter, that is liquids. So if you observe some of the characteristics of these liquids, so if you list out some of the characteristics of these liquids, the characteristics goes like this. As you all know, the intermolecular force of attraction has been increase agirodrinda, they have a definite volume. As your gases, they do not have any definite volume, they take the volume of the container because the intermolecular force of attraction is very, very small. But liquids ಅಲ್ಲಿ ಹಾಗಲ್ಲ, gases ಗೆ ಕಂಪೇರ್ ಮಾಡಿದ್ರೆ intermolecular force of attraction ಜಾಸ್ತಿ ಆಗಿದೆ, ಹಾಗಾಗಿ they have a definite volume, ಅದಕ್ಕೆ ಒಂದು definite volume ಇರುತ್ತೆ. So it has a definite volume. Although they have a definite volume, they do not have a very strong intermolecular force of attraction. So ಇದೇನಿದೆಯೋ intermolecular force of attraction ಅದು gases ಗಿಂತ ಜಾಸ್ತಿ ಇದೆ, but it is not too high to have a definite shape. So although they have a greater intermolecular force of attraction between the molecules when compared to gases, they do not have a definite shape. So as in your solids ಅಲ್ಲಿ ಇದೆಯಲ್ಲ ಆ ಥರ ಒಂದು ಡೆಫಿನೆಟ್ ಶೇಪ್ ಲಿಕ್ವಿಡ್ಸ್ಗೆ ಇರಲ್ಲ. ದಟ್ ಇಸ್ ದೇ ಟೇಕ್ ದಿ ಶೇಪ್ ಆಫ್ ದಿ ಕಂಟೈನರ್. ಸೊ ಫಾರ್ ಎಕ್ಸಾಂಪಲ್, ಇಫ್ ಯು ಟೇಕ್ ಅ ಲಿಕ್ವಿಡ್ ಇನ್ ಅ ಬೌಲ್, ಇಟ್ ಟೇಕ್ಸ್ ದಿ ಶೇಪ್ ಆಫ್ ದಿ ಬೌಲ್. If you take the liquid in a glass, it takes the shape of the glass. So although they have a strong intermolecular force of attraction when compared to gases, they have a definite volume, but they do not have a definite shape. So although this intermolecular force of attraction is strong when compared to gases, they have some fluidity in that. So this is not a rigid state of matter just like your solids. Rigidity irodilla, although the intermolecular force of attraction has been increased from gases, hence they possess the property of flow, that is called as fluidity. Intermolecular force of attraction strong iddaru saha solids ashtu rigidity irodilla, they have a property to flow which is called as fluidity. Hence liquids ke innu one hesru heltare, they are also called as fluids. That is, they have a property of flowing, that is called as fluidity. The gases, the characteristics of gases nodaga, we have seen that it is highly compressible. That is, the gases are highly compressible. Liquids are less compressible when compared to your gases. Gases are highly compressible, these are less compressible. So this is about what is liquid and some of the important characteristics of liquids. Next, let us study about some of the important properties of liquids. The first property we are going to study is about vapor pressure. Before going to what do you mean by vapor pressure, let us take an illustration to explain what is this vapor pressure. So let us take a container and you have a liquid in it. Say it is water or something. Say this is your water. This is your water. And this water is being heated. So let us take, this is a closed container. So you know that what happens now? The water gets vaporized. It gets vaporized. So what is happening? Vaporization ಆಗ್ತಾ ಇದೆ. So this is your water, liquid water, and these are your water vapors. This is your water vapors. At certain time, during this process, at certain time, there is an equilibrium between these two states of matter. ಏನು equilibrium ಅಂದ್ರೆ ಅಂತ, equilibrium ಅಂತಾನೆ ಚಾಪ್ಟರ್ ಇದೆ, ಅದರಲ್ಲಿ ನೋಡ್ತೀರಾ. So as the temperature raises, heat ಮಾಡ್ತಿರೋದ್ರಿಂದ temperature raise ಆಗ್ತಿದ್ದ ಹಾಗೇನೆ the water is converted into water vapors, At certain temperature, on the temperature alli, there is an equilibrium set up between water vapors and your liquid water. At certain temperature, there is an equilibrium is set up between the water vapors and your liquid water. At that temperature, these water vapors, ಏನಿದೆಯೋ ಈ water vapors, they exert a pressure on the surface of the liquid. So think that this is the surface of the water, these are your water vapors. ಈ water vapors ಏನು ಮಾಡುತ್ತೆ, they exert a pressure on the surface of the liquid. The pressure exerted by the water vapors on the surface of the water ಮೇಲೆ ಏನು ಪ್ರೆಷರ್ನ ಆ ಗ್ಯಾಸ್ ಯಾವುದದು ವಾಟರ್ ವೇಪರ್ಸ್ ಎಕ್ಸರ್ಟ್ ಮಾಡುತ್ತೋ that is called as your vapor pressure. So ಏನದು vapor pressure ಅಂದರೆ ಇಷ್ಟೇ, ವೆರಿ ಸಿಂಪಲ್. It is the pressure exerted by the water vapors on the surface of the water at a temperature wherein an equilibrium is set up between the water vapors and the liquid. ಅದನ್ನ vapor pressure ಅಂತ ಕರಿತೀವಿ. So it is the pressure, that is vapor pressure. It is the pressure exerted by the vapors, these are your vapors of a liquid. ಇಲ್ಲಿ liquid ಅಂತ ತಗೊಂಡಿದ್ದೀನಿ, the illustration is with respect to water. So it is the pressure exerted by the vapors of the liquid over its surface ಮೇಲೆ. This is the surface of the liquid, that is water. It is the surface of the liquid over its surface at a certain temperature at which there is an equilibrium set up between liquids and its vapors. So ಇದು equilibrium symbol ಅಂತ ಹೇಳಿದೆ. So ಇದು liquid ಅಂತ ತಗೊಂಡ್ರೆ ಇದು vapors. So there is an equilibrium between liquid and its vapors. So at that temperature, the pressure exerted by these vapors on the liquid is called as your vapor pressure. The unit of vapor pressure is again pressure anta irodrinda the units of pressure, that is atmosphere, bar, etc. So in pressure the units idyo ade vapor pressure the units. So this is about your vapor pressure. The next property you have to study about your liquids is boiling point. So what is boiling point? Already ನಾನು first session allo nimge discuss ಮಾಡಿದ್ದೀನಿ. So it is the temperature at which the vapor pressure, that is the pressure created by the vapors over the liquid, vapor pressure is equal to atmospheric pressure. So it is the temperature, very important. It is the temperature at which the vapor pressure, VP andre vapor pressure of the liquid is equal to the atmospheric pressure. ಎಷ್ಟು atmospheric pressure? 1 bar ಅಥವಾ 1 atmosphere. So when the liquid's vapor pressure attains 1 atmosphere ಅಥವಾ 1 bar pressure ನ attain ಮಾಡುತ್ತೋ, then the liquid starts to boil and that temperature is called as your boiling point. When the vapor pressure becomes equal to atmospheric pressure, the liquid starts to boil. So that temperature, you call it as boiling point of that respective liquid. The next property you have to study about liquids is surface tension. Surface tension is denoted by the symbol. This is the symbol of surface tension. So what do you mean by surface tension? So on the illustration ತಗೊಳ್ಳೋಣ. So you have a liquid. This is your liquid. This is your surface of the liquid. Surface tension ಅಂತ ಇದೆ, which means that some force. So surface tension is a force acting upon the surface of the liquid. Surface tension is obviously a force. Tension anta antidangene you have to remember that there is some force. So surface tension is a force acting on the surface of the liquid. Liquid ina surface ಮೇಲೆ act ಮಾಡ್ತಾ ಇರುವಂತ ಒಂದು force. ಯಾವ position ಅಲ್ಲಿ ಅಂದ್ರೆ it is acting on the surface of the liquid perpendicular to the surface of the liquid. So this is your surface tension. So it's a force acting on the surface of the liquid perpendicular to the surface. So that force acting upon the liquid is called as your surface tension. It's a force acting on the surface of the liquid. Liquid the surface ಮೇಲೆ act ಮಾಡ್ತಾ ಇರೋ ಒಂದು force. It is perpendicular to the imaginary line drawn on the surface of the liquid. So ಇದನ್ನ ನಾನು ಒಂದು imaginary line drawn on the surface of the liquid ಅಂತ ತಗೊಂಡ್ರೆ ಆ ಲೈನ್ ಗೆ perpendicular ಆಗಿ ಆಕ್ಟ್ ಮಾಡುವಂತ ಫೋರ್ಸ್ ನ you call it as surface tension. ಅಂದ್ರೆ liquid surface ಗೆ the force which is acting on the perpendicular direction is called as your surface tension. The surface tension gives you the property, that is, it's a property that gives the spherical shape to liquids. So it's a property of a liquid which gives spherical shape for the liquid droplets. They are spherical in shape, and this spherical in shape is due to the property possessed by the liquids, that's your surface tension. Say for example, you have a droplet of water and a droplet of castor oil athwa honey anta tagondre, the spherical shape ಎರಡಕ್ಕೂ ಇದೆ, ಯಾವುದಕ್ಕೆ, ವಾಟರಿಗೆ ಹಾಗೆ ನಿಮ್ಮ ಕ್ಯಾಸ್ಟರ್ ಆಯಿಲ್ ಅಥವಾ ಹನಿಗೂ ಡ್ರಾಪ್ಲೆಟ್ ಶೇಪ್ ಇದೆ, ಡ್ರಾಪ್ ಶೇಪ್ ಅಥವಾ ಸ್ಪೆರಿಕಲ್ ಶೇಪ್ ಇದೆ. ಯಾವುದಕ್ಕೆ ಜಾಸ್ತಿ ಇದೆ, ವಾಟರ್ಗ ಅಥವಾ ಕ್ಯಾಸ್ಟರ್ ಆಯಿಲ್ಗ ಅಂತ ನೋಡಿದ್ರೆ, ಕ್ಯಾಸ್ಟರ್ ಆಯಿಲ್ ಅಂದರೆ ಒಂದು ಡ್ರಾಪ್ಲೆಟ್ ಆಫ್ ಕ್ಯಾಸ್ಟರ್ ಆಯಿಲ್ ತಗೊಂಡ್ರೆ ಇಟ್ ಇಸ್ ಮೋರ್ ಸ್ಪೆರಿಕಲ್ ಇನ್ ಶೇಪ್ ವೆನ್ ಕಂಪೇರ್ಡ್ ಟು ವಾಟರ್. ಯಾಕೆ ಏನು ನೋಡೋಣ. ಸೊ ಥಿಂಕ್ ದಟ್ ದಿಸ್ ಇಸ್ ಅ ಡ್ರಾಪ್ಲೆಟ್ ಆಫ್ ಯುವರ್ ಹನಿ ಅಥವಾ ಕ್ಯಾಸ್ಟರ್ ಆಯಿಲ್. So there are molecules of castor oil all over this droplet. The molecules of castor oil that is present on the surface has an inward pull. It has an inward pull. The molecules on the surface meliranta castor oil molecules ke one inward pull ide, as well as there is a force acting perpendicular to this surface, which is nothing but your surface tension. So ಹಾಗಾಗಿ castor oil do droplet ಗೆ you have a spherical shape. ಅದೇ ತರ if I take water droplet, a water droplet ಗೂ there is an inward pull, that is the water molecules on the surface, even they have an inward pull, and this inward pull of the surface molecules is due to the intermolecular force of attraction. ಏನಕ್ಕೆ ಆ molecules inward pull ಇದೆ ಅಂದ್ರೆ ಬೇರೆ molecules ಆ molecules ನ ಏನು ಮಾಡ್ತಿದೆ, it is pulling inside, that is due to the intermolecular force of attraction. ಇಲ್ಲೂ ಅಷ್ಟೇ you have a surface tension, that's a force acting on the surface of the liquids. So illu ashte, so there is a surface tension, hagagi water droplets where it will be spherical in shape. Which is more spherical anta helidaga first nanu helide castor oil is more spherical when compared to your water droplet. Eradu droplets they have both the things, inward pull ide, surface tension ide, idukku inward pull ide, surface tension ide. Which is more spherical andre castor oil, honey etc atra hogutte, and that is purely based on, that is the more spherical shape is purely based upon the strength of this intermolecular force. Yake castor oil more spherical liquid when compared to your water andre intermolecular force of attraction in castor oil is greater when compared to your water. So intermolecular force of attraction castor oil ge greater, ade water ge it is weaker. ಇದು ಎರಡರ ಮಧ್ಯ ಕಂಪೇರ್ ಮಾಡಿದಾಗ ಇದಕ್ಕೆ ಇಂಟರ್ಮಾಲಿಕ್ಯುಲರ್ ಫೋರ್ಸ್ ಆಫ್ ಅಟ್ರಾಕ್ಷನ್ ಜಾಸ್ತಿ ಇರೋದ್ರಿಂದ ಇನ್ವರ್ಡ್ ಪುಲ್ ಜಾಸ್ತಿ ಇರುತ್ತೆ, ಹಾಗಾಗಿ ದ ಲಿಕ್ವಿಡ್ ಡ್ರಾಪ್ಲೆಟ್ ಬಿಕಮ್ಸ್ ಸ್ಪೆರಿಕಲ್. ಇದಕ್ಕೂ ಇನ್ವರ್ಡ್ ಪುಲ್ ಇದೆ, ಬಟ್ ವೆನ್ ಕಂಪೇರ್ ಟು ಕ್ಯಾಸ್ಟರ್ ಆಯಿಲ್ ಇಂಟರ್ಮಾಲಿಕ್ಯುಲರ್ ಫೋರ್ಸ್ ಆಫ್ ಅಟ್ರಾಕ್ಷನ್ ಕಡಿಮೆ, ಹಾಗಾಗಿ ದಿಸ್ ಇಸ್ ಲೆಸ್ ಸ್ಪೆರಿಕಲ್ ವೆನ್ ಕಂಪೇರ್ ಟು ಕ್ಯಾಸ್ಟರ್ ಆಯಿಲ್. ಇದಕ್ಕೆ ಇನ್ನೊಂದು ಎಕ್ಸಾಂಪಲ್ ತಗೊಂಡ್ರೆ ಮರ್ಕ್ಯೂರಿ ಡ್ರಾಪ್ಲೆಟ್ ತಗೊಂಡ್ರೆ, ಮರ್ಕ್ಯೂರಿ ಡ್ರಾಪ್ಲೆಟ್ ಇನ್ನೂ ಸ್ಪೆರಿಕಲ್ ವೆನ್ ಕಂಪೇರ್ ಟು ಕ್ಯಾಸ್ಟರ್ ಆಯಿಲ್. That is because ಅಲ್ಲಿ intermolecular force of attraction, mercury droplet ತಗೊಂಡ್ರೆ, you know mercury is a liquid metal, so ಅಲ್ಲಿ intermolecular force of attraction ತಗೊಂಡ್ರೆ it is very stronger than castor oil. ಹಾಗಾಗಿ the virtue of being a spherical in shape for a liquid is purely based upon this intermolecular force of attraction followed by a surface tension. So the property surface tension gives the spherical shape to the liquids. So it gives a spherical shape to the liquids droplets ಗೆ spherical shape ಕೊಡುತ್ತೆ, and the spherical shape of the droplets ಆಗಲೇ ಕಂಪೇರ್ ಮಾಡ್ದಂಗೆ ವಾಟರ್, ಕ್ಯಾಸ್ಟರ್ ಆಯಿಲ್ ಮತ್ತು ಮರ್ಕ್ಯೂರಿ ತಗೊಂಡ್ರೆ it is purely depending upon, that is the spherical shape of the liquid is purely depending upon the strength of the intermolecular force of attraction between the liquid molecules. ಯಾವ liquids ಅಲ್ಲಿ intermolecular force of attraction ಜಾಸ್ತಿ ಇರುತ್ತೋ the liquid droplet become more and more spherical. ಯಾವುದರಲ್ಲಿ weak intermolecular force of attraction ಇರುತ್ತೋ it is less spherical in shape. So this is about your surface tension. The unit of surface tension ತಗೊಂಡ್ರೆ, since it is a force, it's a force acting upon the surface of the liquid perpendicular in direction, force ಆಗಿರೋದ್ರಿಂದ the unit of your surface tension is Newton per meter. Since it is a force acting on the surface of the liquid, the unit is Newton per meter. So the last property you have to study about liquids is viscosity. Before going to define what is this viscosity, you have to know about the flow of liquids. How does the liquids flow? So think that this is a stream of liquid. So this is a stream of liquid flowing. Obviously this liquid is made up of molecules, liquid molecules. The molecules on the surface. So think that this is the molecules on the surface of the stream of liquid. Surface molecules ಏನಿರುತ್ತೆ ಅದರದ್ದು velocity of flow ಅಥವಾ speed of flow it is very less. That is, this layer of liquid will be flowing at a very slow rate. So this is slow. That is stationary ಅಂತಾನೆ ಹೇಳ್ಬೋದು. ಎಷ್ಟು ಅಂದರೆ ಆಲ್ಮೋಸ್ಟ್ ಸ್ಟೇಷನರಿ. ಅಂದರೆ ಸರ್ಫೇಸ್ ಮೇಲೆ ಏನು ಫ್ಲೋ ಆಗ್ತಿದೆಯೋ ಲಿಕ್ವಿಡ್ ಮಾಲಿಕ್ಯೂಲ್ಸು they are almost stationary in nature. That is very slow in its speed of flow, almost stationary ಆಗಿ ಇರುತ್ತೆ. ಹಾಗೆ ಕೆಳಗಡೆ ಲೇಯರ್ ನೋಡ್ತಾ ಬಂದರೆ ಈ ಥರ ಕೆಳಗಡೆ ಲೇಯರ್ ಆಫ್ ಲಿಕ್ವಿಡ್ಸ್ ನೋಡ್ತಾ ಬಂದರೆ ಒಳಗಡೆ ಈ ಥರ ಇಲ್ಲಿ ಒಳಗಡೆ ಏನಿರುತ್ತೋ ಇಲ್ಲಿ ಹೈ ಸ್ಪೀಡಲ್ಲಿ ಹೋಗ್ತಾ ಇರುತ್ತೆ. That is the inner molecules of the liquid will be flowing in a high speed ಅಲ್ಲಿ flow ಆಗ್ತಾ ಇರುತ್ತೆ. That is, as you move on inside inner core ಗೆ ಬರ್ತಾ the speed of the liquid flow increases. That is, the velocity of the liquid flow increases. Very simple. Surface ಮೇಲಿರೋ liquid flow rate ಕಡಿಮೆ, it will flow at a lower velocity. ಒಳಗಡೆ deep inside ಹೋಗ್ತಾ the flow of liquids is very high. That is, the velocity of liquid flow is high. Such type of flow is called as laminar flow ಅಂತ ಕರಿತೀವಿ. So due to the stationary phase, ಇಲ್ಲಿ ಏನಿದೆಯೋ ಸ್ಟೇಷನರಿ ಫೇಸ್ ಏನಿದೆಯೋ ಅಂದರೆ ಇಟ್ ಇಸ್ ಇಮ್ಮೂವಬಲ್, ಮೂವ್ ಆಗ್ತಾ ಇಲ್ಲ ಅಥವಾ ಇಟ್ ಇಸ್ ಮೂವಿಂಗ್ ಎಟ್ ಅ ವೆರಿ ಸ್ಲೋ ರೇಟ್. ಒಳಗಡೆ ಇರುವಂಥ ಲೇಯರ್ಸ್ ಅಂತ ತಗೊಂಡ್ರೆ ಇದು ಬೇಗ ಮೂವ್ ಆಗ್ತಾ ಇಲ್ಲ, ಇದು ಸ್ವಲ್ಪ ಬೇಗ. ಸೊ ಹೀಗೆ ಒಳಗಡೆ ಇರುವಂಥ ಲೇಯರ್ಸು ವಿಚ್ ಇಸ್ ಮೂವಿಂಗ್ ಎಟ್ ಅ ಹೈ ಸ್ಪೀಡ್ ಅಥವಾ ಹೈ ವೆಲಾಸಿಟಿ, ಹೊರಗಡೆ ಇರೋದು ಸ್ಲೋ ರೇಟ್ ಅಥವಾ ಆಲ್ಮೋಸ್ಟ್ ಸ್ಟೇಷನರಿ. ಏನಾಗುತ್ತೆ, ದರ್ ಇಸ್ ಅ ಫ್ರಿಕ್ಷನ್ ಕ್ರಿಯೇಟೆಡ್ ಬಿಟ್ವೀನ್ ದೀಸ್ ಟೂ ಟೈಪ್ಸ್ ಆಫ್ ಲೇಯರ್ಸ್. ಅ ವೆರಿ ಸ್ಲೋ ಲೇಯರ್, ಅ ವೆರಿ ಫಾಸ್ಟ್ ಲೇಯರ್. ದರ್ ಇಸ್ ಅ ಫ್ರಿಕ್ಷನ್ ಬಿಟ್ವೀನ್ ದೀಸ್ ಟೂ ಲೇಯರ್ಸ್. ಸೊ ಇದು ಒಂದು ಲೇಯರ್ ಅಂತ ತಗೊಂಡ್ರೆ, ಇದು ಒಂದು ಲೇಯರ್ ಅಂತ ತಗೊಂಡ್ರೆ, ಈ ಲೇಯರು ಸ್ಟೇಷನರಿ, ಈ ಲೇಯರು ಇಟ್ ಇಸ್ ಅಟ್ ಅ ಹೈ ಸ್ಪೀಡ್ ಅಂತ ತಗೊಂಡ್ರೆ, ದರ್ ಇಸ್ ಅ ಫ್ರಿಕ್ಷನ್ ಕ್ರಿಯೇಟೆಡ್ ಬಿಟ್ವೀನ್ ದೀಸ್ ಟೂ ಲೇಯರ್ಸ್. This friction created hinders this high speed layer to move very fastly. ಇದೇನು ಮೂವ್ ಆಗ್ತಿದೆಯೋ ಅದನ್ನ ಈ ಸ್ಟೇಷನರಿ ಫೇಸ್ ಏನು ಮಾಡುತ್ತೆ, ಹಿಂಡರ್ ಮಾಡುತ್ತೆ, ಮೂವ್ ಆಗದೆ ಇರೋದಂಗೆ ಹಿಡಿದಿಟ್ಕೊಳ್ಳುತ್ತೆ. This hindrance for the flow of this liquid by the stationary phase ಅಥವಾ this hindrance of flow of liquid layers by the other liquid layer ಅಥವಾ by the slow moving layer, ಆ hindrance ನ you call it as viscosity. So ಇದೆರಡರ ಮಧ್ಯ there is a friction created. ಯಾವುದ್ರ ಮಧ್ಯ? ಸ್ಲೋ ಮೂವಿಂಗ್ ಸ್ಟೇಷನರಿ ಲೇಯರ್, ಹೈ ಸ್ಪೀಡ್ ಲೇಯರ್ ಅಂತಾನೆ ತಗೊಂಡ್ಬಿಡೋಣ. ಯು ಟೇಕ್ ಇಟ್ ಆಸ್ ಲೇಯರ್, ದಿಸ್ ಇಸ್ ಲೇಯರ್. ಸೊ ಸ್ಲೋ ಮೂವಿಂಗ್ ಲೇಯರ್ ಮಧ್ಯ ಮತ್ತೆ ಹೈ ಸ್ಪೀಡ್ ಮೂವಿಂಗ್ ಲೇಯರ್ ಮಧ್ಯ there is a friction created. This friction resists the flow of liquid. This friction created between these two types of layers in a liquid which is flowing in a laminar flow type hinders or resists the flow of liquids. This hindrance athwa resistance offered for the flow of liquid is called as your viscosity. So what is laminar flow? Nodidivi. The regular increase in velocity from one layer of liquid to other layer, stationary to high speed layer. Due to this laminar flow, ಈ laminar flow ಇರೋದ್ರಿಂದ liquids ಅಲ್ಲಿ there is a friction created between one part of the liquid to other part of the liquid. That is high flowing layer ಗೂ ಮತ್ತೆ low flowing layer ಗೂ, that is stationary layer ಗೂ there is a friction created. This friction hinders ಅಥವಾ resist the liquid flow which is called as your viscosity. Definition of viscosity ತಗೊಂಡ್ರೆ, it is the measure of resistance ಅಥವಾ hindrance offered to the flow of liquids. The reason is friction. Offered to the flow of liquids is called as your viscosity. What is the SI unit of viscosity? SI unit is Newton second per meter square. So that's the SI unit of your viscosity. So this is about your liquids, the characteristics of liquids as well as some important properties of your liquids. So with this we have completed the states of matter.